Okay, we're gonna jump into Module 3, Lesson 1 right here. And you should have done this exploratory challenge, and we're just going to go through each pair pretty quickly. You were supposed to determine if they were similar to one another and explain. So, on A, yes, they are similar because they have the same shape. B, no, they're not similar because they have different shapes. Yes, same shape, same size. No, or yes, sorry, same shape. And when we're talking about similarity, we have to be very, very precise when we're talking about this. So we have to make sure that we're staying on the same page and being very precise. E here, yes, they're the same shape. Yes, same shape. On G, this is no. They don't have the same shape. If you look at it, the mouth is the same proportion, but the eyes and the circle is not. So no, because they're not in proportion. To each other. Pair H, they are similar, okay? Because those are called parabolas, and they are the same shape. Okay, and what we're going to do in this unit over the next couple of lessons is talk specifically about dilation. And now everything I write on the notebook paper, you need to write on a piece of notebook paper or on something else, because we're going to talk about dilation. So let's start with the definition. A dilation magnifies or shrinks an image. Okay, so it's going to make something bigger or it's going to make something smaller. Okay, and we're going to talk about how this works. So if you see a dilation of O, okay, that means that the center is O, okay? A dilation of whatever, the center is O, and it doesn't move, okay? Now, this is what you'll see several times when we're talking about dilation. So a dilation moves each point along a ray. So we're going to start with a ray. And we're going to say, okay, this is O. And I have point P. And a dilation is going to take the distance from O to P and multiply it by some number. And it's either going to get bigger or smaller. Okay, and we would have something like P prime out here. And what this is the distance from there is your scale factor multiplied by the distance from O to P. So we're going to look at this a lot. And when you see this OP, all that means is the distance from O to P. Okay, all this means right here is the distance from O to P. Okay, so before you've made scale drawings and you've made things larger or smaller. Okay, and in geometry you have to be very specific about those things. So when you shrink a figure, okay, your scale factor, which is R, I guess I should write that in. Okay, R is the scale factor. And all we're doing there is multiplying them. So to shrink a figure, okay, your scale factor is greater than 0 but less than 1. So it would look like this, 0. Okay. So all of the points will move towards O, your center. To magnify a figure, your scale factor is greater than 1. So that would be R is greater than 1. Okay, so what if R is exactly 1? What if our scale factor is 1? If our scale factor is 1, okay, then the figure doesn't change. It doesn't get bigger, it doesn't get smaller. It remains congruent to the original figure. Similar to this example here, same. Here we went from a small one to a big one, it magnified. Here we went from a big one, oh my nails are gross, big one to a small one, it shrank. Okay, so now we're going to look at some examples, and I'm going to write these down here. Okay. So you have a segment OP equals 3 centimeters. Okay. And you're going to dilate it by a scale factor of 4. Okay, so we're taking our original length we're going to find OP prime, and we're taking our original length and multiplying it by our scale factor. So our scale factor was 4 times the length from O to P, which was 3. So the distance from O to P prime would be 12 centimeters. Okay, that's one example. Okay, we have to keep them proportionally the same. Another example, we have OQ. Let's see this. OQ is 21 centimeters. Okay. And we're going to dilate it by a scale factor of 1/3. So we want to figure out the length from O to Q prime. So we're going to take our scale factor times the length from O to Q. So our scale factor is 1/3, and we're going to multiply it by the length from O to Q, which was 21. So 1/3 of 21 is 7 centimeters. Oh, you can't see that. Okay, so this is how we're going to set up our equations in this thing. So now we're going to go back and we're going to head into our exercises. Okay, if we were just looking at a diagram like this, okay, like these, to determine if one is a dilated version of another, you can measure the original lengths of all the parts and check to see that the lengths of the original figure are multiplied by the same scale factor to equal the dilated lengths. So you could measure this length, multiply it by the scale factor to find this length. And if it's the same, then it is a dilated version. Okay, so now we're going to hop right into the exercises here. Okay, given segment OP is 5 inches. If segment OP is dilated by a scale factor of 4, what is the length of segment OP prime? So just like we did before, the distance from O to P prime equals a scale factor times the distance from O to P. So our scale factor was 4 times the distance from O to P was 5. So the distance would be 20 inches. Okay. Here we're just using a scale factor of 1/2. So the distance from O to P prime would be our scale factor times the distance from O to P. So our scale factor was 1/2. Our distance from O to P was 5. So 1/2 of 5 is 2.5 inches. Okay, so what we have been doing down here is using the definition of a dilation, where we just use it the whole time that we know the scale factor times the original length is our new length. That's the definition of a dilation, and we're going to stick with that as we work through this. Okay. Use the diagram below to answer questions 2 through 6. Let there be a dilation from center O. Then dilation P equals P prime, which is out here. So we're going to take this and multiply and get P prime. Dilation of Q equals Q prime, so we're going to take this and get all the way out to Q prime. OP is 3 and OQ is 4. If the scale factor is 3, what is the length of OP? Okay, OP prime, sorry. So if this is 3 and our scale factor is 3, we just say 3 times 3 equals 9 centimeters. And then we would go and we would do the definition of a dilation. The length from O to P prime equals the scale factor times OP. So our scale factor was 3 times the length from O to P, so 9 centimeters. If the scale factor is 3, what is the length of the segment from O to Q? So O to Q prime, sorry. So O to Q was 4, So our scale factor times our length times our scale factor would be 12 centimeters. So if we did the definition of a dilation, okay, we would say the distance from O to Q prime equals our scale factor times OQ. So our scale factor is 3 times the distance from O to Q was 4. So that would be 12 centimeters. If you know that OP is 3 and that OP prime is 9, how could you use the information to determine the scale factor? Well, if we use the definition of a dilation, the distance from O to P prime equals our scale factor times the distance from O to P. Okay, we know the distance from O to P is 9 equals our scale factor times the distance from O to P is 3. We have an equation, and you should be able to solve this equation because you guys have been working on them. You worked on them in 7th grade. So if we want to get R by itself, we would divide both sides by 3. And then we would get R, 9 divided by 3 is 3. That is how you would just work it backwards to solve for the scale factor. Okay? So, for every positive number, okay, this is just talking about the definition of a dilation and how we move a point along a ray to do this lesson.